Welcome learners in today's lesson. Today we're going to look at program design tools. So these are tools that allows one to come up with a design, represent a design, and a design is basically a plan of a given program on paper. So the design or the plan is called an algorithm, and basically an algorithm is a step-by-step procedure followed while solving a given problem. So there are various ways in which you can represent an algorithm. One, you can use a program, and then you can use what you call a pseudocode. You can use a flowchart. So these flowchart pseudocode programs are examples of tools which can use to represent what you call a plan, and you're saying the plan itself is not what you call an algorithm. So we can start by looking at a pseudocode, and a pseudocode basically narrates your steps using the English vocabularies, but you follow the rules, the syntax of a given programming language concerning how you name your data, concerning things like punctuations, etc. So we can start by looking at an example of a pseudocode. So I have an example of a pseudocode to add to numbers. So in this problem, you have to analyze and know what are the data, what is the formula or way of converting the data into information, and which is basically information. So we can start step number one. Always your pseudocode must have a start, and the last step is always end. So we have to declare variables. Declaring variables means state the variables you require in your problem. So here we require num1 as the first number, num2 the second number, then the sum is basically information or the output. Now between these three variables, we are saying num1, num2 are the inputs, then sum is basically an output. We say get inputs. Well, how can we get inputs? We simplify this step by saying enter num1 and num2. Each and every step must be represented in its simplest form. You cannot use what you call ambiguous steps. Another step is complete sum. So how do we complete sum? You can say sum is equals to num1 plus num2. We are taking the value of num1, then we add to the value of num2. Then we print sum. Another example of a pseudocode to determine a positive number. We want to check whether a given number is positive. In this problem, it means you have one variable which is number. Then you have to check whether that given number is positive. To do that, use the concept of number line. We say that positive numbers are those numbers that are above 0 on the number line. So we are saying always your pseudocode, the first step is start and the last one is stop. So from there we declare variables, and we are saying we only need one variable, which is num. Then I get inputs. I use us to enter the value of num. We say enter num. Then step number 4 is compute positive. Calculate for positive. How do you calculate positive number? We say if. So the keyword if means we are coming up with a condition. We are coming up with a test, which the computer will evaluate, and the answer is either yes or no, depending on that given condition and the data. So I say if number greater than 0 is an example of a condition. If number greater than 0, meaning we are asking a question. Depending on the value of the number that one has entered, the answer can either be yes or no. So if it is yes, then we choose, we print the positive number. If it is no, we will not print the positive number. So it means using this pseudocode, you want to make a choice, either printing positive number or not printing positive number. To do that, we are coming up with a condition. Another example can be, I want to determine the largest number among two numbers. Print the largest number among two numbers. So here, I will be needing two variables. One is num1, another variable will be num2. So I get two numbers. Then I say enter num1 and num2. I require input of num1, first number, and num2, which is the second number. Then I compute for largest. Calculate largest number. Compute largest. How will we compute the largest? We have to compare. So we come up with a condition. If num1 is greater than num2, is num1 greater than num2? The answer is either yes or no. If it is yes, then we can say print that num1 is the largest. We display that num1 is the largest. If it is no, it means we can say else we print num2 is the largest. Num2 is the largest. Then we stop. Number 5 we stop. So basically, here else means otherwise, and otherwise means opposite of this condition. When this condition returns yes, it will choose this choice of display that num1 is the largest number. Else means opposite of this, meaning the value of num1 is not greater than the value of num2. So we display that num2 is the largest. So in this pseudocode, we are trying to make choices between this, saying that num1 is the largest, or choosing that num2 is the largest. To achieve that, we are coming up with a condition, and we are saying this condition returns either yes or no. So if it is yes, we make a choice. If it is no, we make another alternative choice. Then you can move to another example, and this example involves performing activities several times or repetitively. Here is a pseudocode for displaying welcome 10 times on the screen. So it means you are repeating that activity of displaying welcome several times, and it has to be 10 times on the screen. So to achieve that, we are saying start, declare variables. Here we only need one variable, and this variable is a timer, is a stopwatch, which will monitor for us the 10 repetitions. Give us intervals, and there must be 10 intervals. So this variable has two components. One is initialization. Here we call it a loop control variable, which controls repetitions or iterations. So this variable has one component which is known as initialization, which involves setting the starting point of the timer or the variable. This is how we can set initialize variable. We are setting counter to start at 1, our timer to start at 1. And we are saying this timer known as counter is used to give us intervals, changes, and at each change, we are repeating this activity of displaying welcome on the screen. So once it is 1, we repeat. Repeat means we perform several activities several times. And the first activity here is printing welcome. So welcome will appear, first line of welcome. Then we come and repeat this also line, increase counter. We are coming up with another interval. We are manipulating this counter to give us another change. So we are saying count is equal counter plus 1. 1 plus 1, it becomes 2. We go back and repeat until counter reaches 10. Which is counter is 8, we repeat. It is 9, we repeat. It is 7, we repeat. But once counter reaches 10, we stop. So we are saying we are starting counter at 1, increasing it by 1 until it reaches 10, and whatever we are repeating here is displaying welcome. So welcome will appear 10 lines or 10 times on the screen. So I say whenever you come across a task which requires repetition, performing certain activities several times, you have to utilize the concept of iteration, and in your pseudocode you have to have a keyword repeat. If you are coming up with a problem or task that requires making choices, in your pseudocode you have a keyword if. You don't use if, it means the pseudocode will be wrong. So if it means you are making choices, they repeat, or what you call for, you can also use for. What you call do means we are performing activities several times. And basically we are saying in repetition, we require a timer, we require a variable that will monitor for us or give us intervals which we are using them to perform various activities. And these variables have what you call 1, initialization. The number 2 is a condition. A condition is a test that returns either yes or no. If it is yes, the loop will continue. If it is no, the loop will stop. This is an example of a condition which defines how many times the loop will run. Then the last component is known as order, and order defines the manner in which you are supposed to perform our repetitions in an incremental manner or in an incremental manner. So these are statements, an example of order, which we are using to manipulate the timer so that it can give us intervals so that we can perform a given task. So basically these are examples of pseudocode, and we are saying pseudocode can be in terms of sequence, selection or making choices, and this is an example of pseudocode on repetition. Then you can move to another tool known as flowchart, and the flowchart uses a diagram to come up with an output in form of a solution to a given problem. So it has special symbols which it uses to come up with what you call an output or a solution. So basically there are basic symbols. One is a small rectangle for process activity. If you are transforming data using a rectangle. Another is this shape. This shape means start activity or stop activity. Whenever you start and stop you have to use that particular symbol. Then you have a diamond, and the diamond refers to decision or making choices. Decision or making choices. Then you have directional keys in terms of arrow keys. And these basically are just lines that allows us to define the flow of logic or reasoning in your flowchart. Then you have a small circle, which is basically a connector. It's not a connector. Once I'm drawing a flowchart, then it doesn't fit on my page, I can connect and move to another page so that I continue drawing my flowchart. So you can look at an example, a flowchart that is used to calculate area of a circle. So we have to have one start, just indicate inside start. Then you connect with an arrow pointing down. Here we have a constant pi, and pi in programming, we just give it a name like pi. We don't use a symbol pi. In programming, give it a name, then you give it a value 3.14. You cannot enter this particular symbol using the keyboard. So you normally come up with a name, then you assign a value 3.14. It means this value will not change. So a constant is a variable whose content remains the same during program execution. So you can say pi is equals to 3.14. We are using a rectangle because initializing is an example of an activity that falls under processing. Then from there we come up with this shape. This shape will allow us to enter for entering. So you say enter radius. Enter radius. So radius is a variable whose content we keep